Good morning, class. Today is our very first flipped lesson. I'm so excited that we're trying this as a class. Go ahead and take out your math journal and your star reference materials for math. You need to have both of those out on your desk while we're doing this lesson. Open up your journal to the next available page. You need to title it Customary Conversions. Now, customary conversions are very similar to metric conversions. The only difference that they have is that in a metric conversion, we are using powers of tens. That's what we learned last week. In the customary conversions, we'll be using whole numbers, perhaps decimals and fractions. And we'll have to be dividing and multiplying those whole numbers, decimals, and fractions. Metric conversions were a little bit easier because all we had to do was multiply and divide by powers of 10. So we're going to get right into it, and we're going to start with an example problem. Our first problem is going to be 9 tons is equal to how many pounds? This is example 1. Now, last week when we did metric conversions, I explained that it is necessary for our units to be on top of units. So, our next step is going to be to look at our reference materials and find our tons and our pounds. Alright, here is our reference materials. We again are looking for tons and pounds. So if you look at the bottom left corner, we have 1 ton is equal to 2,000 pounds. This is the conversion we are going to use to help us convert our problem. Now back to my problem. I know that 1 ton is equal to 2,000 pounds. So again, I need to make sure that my units are on top of my units. So I'm going to write down 1 ton is equal to 2,000 pounds. Alright, so now I look at my numbers, and I'm looking at my numbers besides 1, and I need to check, are they diagonal from each other or are they on top of each other? If I look at my example, I notice that my numbers are diagonal from each other. This means that we are going to be multiplying. So, I need to set up my conversion. So I have a problem that I need to solve. Again, I said we're multiplying. So we're going to be multiplying 9 times 2,000. Now, multiplication of whole numbers is something that we've already learned. So when we set this up, we need to multiply regularly how we would any other day. So 9 times 2,000. 9 times 0 is 0. 9 times 0 is 0. 9 times 0 is 0. And 9 times 2 is 18. That means that 9 tons is equal to 18,000 pounds. Pretty simple, right? Okay, we're going to get a couple more examples. So, next problem. Example number 2. I am going to be converting 4 3/10 quarts, and I want to know how many pints it's equal to. So we're converting quarts to pints. So again, you need to pull out your reference sheet, and I want you to look for quarts and pints. I'll give you a second. Our reference sheet tells us that 1 quart is equal to 2 pints. So again, units on top of units. So 1 quart is equal to 2 pints. Alright, so now my next step. I look for my numbers besides 1 and see, are they diagonal from each other or on top of each other? In this case, they are diagonal from each other. This means we are going to multiply. So now it's time to set up my problem. I have 4 3/4 multiplied by 2. again, I need to set up my multiplication problem. So 4 3/10 quarts times 2. Well, 3 times 2 is 6. 2 times 4 is 8. Now I have a decimal. Remember, when you have a decimal in a multiplication problem, you move your decimal to the end of the problem. And then you take it in your answer. Remember, all our answers are whole numbers to begin with. And you move that decimal to the opposite direction, however many times you moved it in your problem. So this means my answer is 8 6/10. And we were looking for pints, so I need to make sure I include my units. 8 6/10 pints. Next example. Example number 3. In this example, we are going to convert 7 9/10 liters, and I want to know how many milliliters is this. Again, take out your reference chart, and I want you to look for liters and milliliters. Now, what do you notice about this? This isn't on our customary side. This is actually on our metric side. But just like our customary side, we're going to set it up the same exact way. If I look at my reference chart, I know that 1 liter is equal to 1,000 milliliters. So again, units on top of units. So 1 liter is equal to 1,000 milliliters. My next step is to look. Do I have my numbers diagonal to each other or on top of each other? Here, we have them diagonal to each other. Since our numbers are diagonal from each other, that means we are going to multiply. So, now I need to set up my problem. I have 7 9/10 liters, and I'm going to multiply by 1,000. Now, 1,000 is a power of 10. So the strategy that we learned last week tells us we need to move our decimal. I count my number of zeros. I have 1, 2, 3. This means we're moving our decimal 3 times. Now, when we multiply, we move our decimal to the right. So, taking my problem, 7 9/10, that means I'm going to move my decimal 3 places to the right. Now, what do I do with those empty spaces? Yes, I need to add zeros. This means my final answer is actually 7,900, and my units should be milliliters. Perfect. Now, I'm going to want you to try 3 on your own. Using your reference chart, I want you to try the following 3 problems. First problem that I want you to try. 156 inches is equal to how many feet? Problem number 2. 9,237 centimeters is equal to how many meters? Number 3. 8 7/75 pounds is equal to how many ounces? Now, I would like you to do these on your student side, and you can pause the video now, and I want you to work all 3 out. Alright, now that you've worked them out, we're going to check. Make sure that you've worked these out before you move on to this step. We're going to start with problem number 1. Problem number 1 was 156 inches is equal to how many feet? So, if I look at my reference chart, I know that 1 foot is equal to 12 inches. Now, on our reference chart, foot comes first, but we know that our units need to be on top of our units. So if I put 1 foot, I know that that is equal to 12 inches. Now I have units on top of units, so I'm good to go. Now looking at my setup here, I need to see, are my numbers on top of each other or diagonal from each other? In this case, they're on top of each other. This tells me that I am going to divide. Alright, so now it's time to set up my problem. I have 156 divided by 12. Now this is a division problem, so I need to set it up. 156 divided by 12. The very first thing that I should always do is make a T-chart. I'm making a T-chart for 12s. Remember, I like to go up to 5, but you're more than welcome to go up all the way to 10 or even farther if you'd like. So counting by 12s. 12, 24, 36, 48, 60. If needed to go farther in our T-chart when we start dividing, we can do so. Alright, so starting on my division, I look at my division problem. Can 12 go into 1? No. So I can put an X or a 0 up there. Can 12 go into 15? Well, looking at my T-chart, yes it can. It goes in 1 time. 12 times 1 gives me 12. When I subtract, I get 3. I have a remainder, so I have to keep going, and I need to bring down my 6. 12 goes into 36 3 times. 12 times 3 gives me 36. I have a remainder of 0 and no more numbers to bring down. So my answer is 13. This means that 156 inches is equal to 13 feet. Perfect. Problem number 2. I have 9,237 centimeters, and I want to know how many meters it is equal to. Looking at my reference chart, I notice it's on the metric side. So I'm looking for centimeters and meters. It says 1 meter is equal to 100 centimeters. Again, meters came first in this conversion, but I need to make sure that I have units on top of units. So 1 meter is equal to 100 centimeters. Next step, I look to see, are my numbers diagonal from each other or on top of each other? In this case, they're on top of each other, which means we are going to divide. So now I need to set up my problem. 9,237 divided by 100. Now 100 is a power of 10. So I look and count how many zeros I have in that power of 10. I have 2. Now when we divide, our decimal gets moved to the left. Now in our number 9,237, where is my decimal? You're right, it's at the end. It's a whole number, so our decimal is always at the end. So I'm dividing and I have 2 zeros, so that means I'm moving my decimal 2 places to the left. 1, 2. My decimal ends here. So my answer here would be 92 and 37 hundredths, and we were looking for meters. This is my answer. Problem number 3. I have 8 and 75 hundredths pounds, and I want to know how many ounces is it equal to. Now, I look at my reference chart once again, and I notice that, well, let's see, we're going pounds to ounces, so that's under the weight and mass section, and it says 1 pound is equal to 16 ounces. My next step is to see where my numbers are at. Do I have my numbers on top of each other or diagonal from each other? Well, I have them diagonal from each other. This means I am going to multiply. So, time to set up my problem. 8 and 7/500 pounds times 16. And now I'm ready to multiply. Remember, when you're multiplying decimals, forget about the decimal to begin with. Let's just multiply regularly. 5 times 6 is 30. 7 times 6 is 42. 42 plus my 3 that I've brought up is 45. 8 times 6 is 48. 48 plus that 4 is 52. I drop my 0. Now, I want to cross out what I've already used, and then I can start over. 1 times 5 is 5, 1 times 7 is 7, and 1 times 8 is 8. And I add these up. 0 plus 0 is 0. 5 plus 5 is 10. I carry my 1. 7 plus 2 is 9, plus 1 is 10. Carry my 1. 1 plus 5 is 6. 6 plus 8 is 14. Now, this is a whole number, so my decimal is at the end. Now, since we had a decimal to begin with in our problem, I need to move that decimal until it's to the end of the number. I moved it twice. This means in my answer, I'm going to have to move it twice in the opposite direction, which is to the left. So, my answer is 140 ounces. Alright guys, this completes our lesson for today. Now, remember, you can always rewind, fast forward. Now, I wouldn't want you to fast forward because I don't want you to really miss anything, but you can rewind, you can pause, and if you have any questions, you can actually go back and look at this from home. So, this concludes our first flipped lesson. I hope you liked it. And tomorrow or later on today, you will get an opportunity in your small group to work with me on guided practice. See you next time.